Okay, so I am having a lot of trouble doing these equations, so I figured you guys needed help if I needed help doing them. So we have two equations that we're looking at. We're looking at T lag, they'll call that lag time, which is how much lag time, that's lag, there is per 100 kilometers. So when you're doing that, you always take 100 over v of one wave minus 100 over v of the other wave, and that's going to come out as your lag time, right? And it's kind of absolute value, so that it doesn't really matter which v. One could be vs, one's vp, and it doesn't really matter. The other equation is distance, and my distance is equal to the 100 kilometers per the lag time, which we just calculated. That says T lag. That is really hard to write on my little board. And then that's times the time that there is on the seismogram, right? So this is equation 1, and this is equation 2. And again, that looks horrible. Let's see if I can make that a little better. This should be LAG, right? It's the same. These things are the same. Lag. All right, so let's start. So this first one, we look at the numbers that it's giving us, and we've got 80 seconds, 100 kilometers, 6.2 seconds, right? And so we see a seismograph shows the time lag between a P and an S wave is 80 seconds. So that time lag, right, is T. Oops, I wanted to make that this. That's T. And then it says 100 kilometers per 6.2. So this is my T lag. All right, so you see the difference. So one's the time on the actual seismogram, and this is the lag time per 100 kilometers. So in my given, I'm going to have T is equal to 80 seconds. And my lag time, T lag, is going to be equal to 100 kilometers per 6.2 seconds. So I know it's not in time, but that's what we're going to call it, right? So 6.2 seconds for every 100 kilometers. And we're trying to figure out the distance, d. So I can see I'm going to use equation number 2, right? Because 2 has the d in there. So d is equal to 100 over t lag, and then times t. So I guess technically I shouldn't have called this. I should have called this 6.2 seconds. Let's make it consistent. So 6.2 seconds. So it matches, right? Because the 100 I left here, right? So the 100's already there. So I don't need to have the 100 again. And so then once we know that, right, we don't really need to do anything for solve. It's the same. So solve d is equal to 100 over t lag times t. So then when we solve it, we'll put in our units to make sure everything matches, because that's always important. So 100 very messy. Let's make it a little prettier. So this is t lag. And so this would be 100 kilometers per 6.2 seconds times 80 seconds, right? So 80 seconds. So if I pull out my trusty dusty, my handy dandy calculator, we do 100, we divide by 6.2, and then we multiply by 80. So that would be 1290. Now, the actual answer on my calculator is 1290.3 kilometers. So that's the real answer. But in the answer you would type in is 1290, because I have to round to the nearest whole number and not put in units. So remember, when you're putting it in, you're putting in the number rounded, right? So 3 rounds down to 90, and I don't put in the kilometers, right? When you do the quiz, you'll have to show the units and the actual number, but when you type it in, you only have to type in that number, so we're sure you're close. All right, let's try the number 2. So if the velocity of a P wave is 9 kilometers per second and the velocity of S wave is 3 kilometers per second, what is the lag time? All right, so now we're trying to find lag time. So in my given, we know that VP is 9 kilometers per second and VS is 3 kilometers per second, and I'm trying to figure out the lag time, so call it T lag. And so the equation, we know T lag is going to be equal to 100 over V of one of them. And again, it doesn't matter really which one, 100 over V of the other one, right? Because it's absolute value. So I really don't care which way I subtract it. It doesn't matter. So it's already solved for me. So T lag equals 100 over VP minus 100 over VS, right? So I'll smooth this up a little bit. Right, and so when I plug it in, put your units to watch. So it should be 100 kilometer. That is not a kilometers, and that doesn't look like 100. So let's try that again. So 100 kilometers per, and VP is right here, right? So I'm putting that one here. So VP is 9 kilometers per second. That whole thing minus 100 kilometers over, now VS is this one, right? So plug that one in there. And so VS is 3 kilometers per second. Now I like to do it like this because this is where I always mess up. Make sure my units match. So kilometers, kilometers, S comes to the top, kilometers, kilometers, S comes to the top. So now I know, yes, that is going to work. So now I can plug in all my numbers in my calculator, and I end up with 100 divided by 9, which is 11.11, and 100 divided by 3, which is 33. So notice that's going to be a negative number because I put the one first and the other one second. But again, it doesn't matter. You just want the difference in time. And so then I subtract. So the actual answer comes out to be 22.22 seconds per 100 kilometers, because that's the definition. But in Google Classroom, I wouldn't write that. I would write 22, because remember, it only takes whole numbers and no units. All right, hopefully that helps. Good luck doing the rest of them. So I did 1A and 2A for you. You have to do the B's, and you have to do the 3 and the 4, and this should definitely help you for the quiz you're going to do.